All right, welcome back to Daily Maths Concepts. What we're doing today is question 4 from the June 2022 Add Math paper 2. This is introductory calculus. It says all working must be clearly shown. Question 4 reads, given that f of x is equal to x open bracket 5 minus x squared, determine the double derivative here. So that's a derivative symbol there. We're supposed to determine the double derivative. So here we go, double derivative. So we're looking at, that's right now what we're looking at. We're looking at, say, f of x is equal to x open bracket. We have 5 minus x, that square. And we wanna determine the double derivative there. So what we're gonna do is just to take the first differential first. All right, so we're taking the first differential. But before we do that though, what we wanna do, we could break this down into some polynomial things. So we could just take this aside and say, all right, if I have x and I have 5 minus x squared, I could rewrite that as x. Then when I square that binomial, I'll definitely get 25. 5 times negative x is negative 5x. On the double that, we get negative 10x, and then x squared would give us that. All right. So we're looking at that idea, and then we distribute that x inside. So when we distribute the x inside, I'm looking at 25x minus 10x squared plus x cubed. All right. So I'll definitely have that. So that is what we're really going to be differentiating here. We could set it up anyhow we want it. So if we want to put it like put that out front and do that, it's fine. So we could set it up how we want. So basically we are representing this here. All right. So now we have that. We can now go ahead and just take the first differential, right? So the first differential, as we know, is going to equal to 3. Then we have x raised to the second, subtract the power there, subtract 1 from the power, then negative 2. We're going to have 2 times negative 10. That's going to give us negative 20. And then that is x. And then that, there was an x here. And then that 25x becomes 25, right? So that 25x actually becomes 25 right there. So that's taking that first derivative right there. All right, so the bottom line is that that's the first derivative. So we're gonna go again, right? So for the second derivative, we're going again. So 3 times 2, that is 6x, and then the negative 20x becomes negative 20, right? So that is actually our second derivative right there. All right. So let's look at the next question. All right, so the next question says, differentiate each of the following expression with respect to x. All right, so we're looking at this here. I want to differentiate with respect to x. So right there, differentiate with respect to x. All right, no problem. So basically, what we could do here is just to say, all right, let's go. So we're doing, let us say we have y is equal to 2 sine 3x plus cos x, and we're doing our dy dx here. Basically, the differential of a sine is a cos, so this is going to give me 2 cos 3x, and then I would have to go and take the derivative of the angle to multiply back by everything. So I have a 3 there. And then the differential of the cos is a minus sine x. So we would have had that. So when we simplify this, we basically would have 6 cos 3x, if you want, minus sine x. So there it is. That's the differential of that. Let's see what else we have. All right, so we have 1 plus, so we have 1 plus 2x to the third, and then it's going to be multiplied by x plus 2. What we could do here is to apply the product rule. Yeah, we could apply the product rule. We could treat this as a f, we treat this as a g. So basically, let us say y was equal to all of that. So then dy dx is going to equal to f with the differential of the g function plus the g function with the differential of the f. So we set up this and we work it through. All right, so basically, let's go for that. So dy dx is going to be equal to, let's write back the f, this one. So we have 1 plus 2x to the third. And then we're going to take the differential of this, which is just that. So it's just a 1, right? With a plus. And then we're going to write back this one here first. So we have that. And then we're going to take the differential of the f function, which is to actually, the 3 will come down. So let me just put it there. So the 3 will come down, and then it's going to be multiplied by everything there, which is 2x. It's going to reduce, so it's going to be to the second. And then we're going to have to go inside and take the derivative of this part. So it becomes a 2 out there, right? So basically, that's what we have. Then we want to simplify this. So let's write this back. So we have 1 plus 2x to the third. And then for this part, 3 times 2, I'm going to put the 6 out front for the 3 times the 2 here. And then in bracket, I would have x plus 2 times 1 plus 2x squared. Right? So basically, that's what I would have right there. And this, I'm seeing where I could factorize out this though. I could factorize like, I could factor out 1 plus 2x squared. If I factorize out that, I'll get 1 plus 2x here. And I'll get plus 6. I could distribute this. I could just say 6x plus 12 right there, right now. And then I could clear up on the inside, basically. So I could have 1 plus 2x squared. And this is going to be multiplied by, let's put this together. That's 8x plus 13. And I could leave it there. I could leave it here. So I'll just leave it there. The dy dx would have given me that. So that's what else that we have here. All right. This question says determine the stationary point. Right? It says determine the stationary points of the curve y is equal to x cubed. All right, minus 4x. All right, good. So we're going to go for the stationary point here. So in going for the stationary point, we want to establish the fact that if I'm going to go for the stationary point, my dy dx must equal to 0. So this is my gradient function. And when the graph is stationary, my gradient function is equal to 0. So here's the deal. Let's go for the gradient function. So getting the gradient function, dy dx is going to equal to, we're working with this, so we're looking at 3x squared minus 8x plus 4. All right, so this is my gradient function. And when the graph is stationary, this function is equal to 0. So we're saying 3x squared minus 8x plus 4 is equal to 0. So we are stationary when this is equal to 0. Now we could do some quick factorization, Mike. So when you do your factorization, you'll work out your thing to find out at the end of the day that if I factorize this, I'm looking at x minus 2 into 3x minus 2. This is equal to 0. So if we check this out, -6, we'll end up with that. So this is factor. All right, so it's in factor form now. So now we could solve, because when you look at this, then x minus 2 is equal to 0. So we could say x is equal to a 2. So that's one case. And then in another instance, we're talking about where 3x minus 2 is equal to 0, and x here is equal to positive 2/3. All right, so we're looking at these. What we want to do though at stationary point, we want to plug back these. We want to evaluate these in the function to get the y value. So if I try to get y, so when x is equal to 2, so when x is equal to 2, I want to know what this is, what the y value is. So it is x cubed minus 4x squared plus 4x. Right? So I'm going to substitute 2 there. So 2 to the third minus 4, 2 squared plus 4 times 2. So this is going to give me 8. 2 to 4 minus 16 plus 8. And this is a 0. So then this is suggesting that my first stationary point is a 2, 0. Right? So that's stationary point 1. Now, I could find the other stationary point right now because I want to know when x is equal to 2/3. So I'm going to still substitute in this function x to the third minus 4x squared plus 4x. Remember that x is equal to 2/3. So I'll have 2/3 to the third minus 4 times 2/3 squared plus 4 times 2/3. Could go ahead and put this on our calculator one time, but we could work out a little bit. I'll end up with 8 over 27. This part give me 4. So this is 16 over 9. And this is going to give me plus 8 over 3. Right. So I'll have all of that. And if I want to show all my working, then I could just say, all right, guess what? 27 into itself 1 times 8 gives me 8. 9 into 27 goes 3 times. 3 times the negative 16 negative. All right, let's go again. All right. And then 3 into the 9, 3 into the 27, that's 9, and 9 times 8, that is 72. So 8 minus 48 plus 72 will give me 32 over 27. So this means that my second stationary point is 2/3 32 over 27. There we go. Our stationary point 1, stationary point 2. Right? So would have collected those 4 marks right there for that. Now it says provide details. All right, determine the nature of each of the stationary points. What's the context here? The context here is that at my stationary point, if I want to evaluate the nature of the stationary point, I'm going to go by double derivative. So I'm going to go d squared y, all right, dx squared. So I'm going to take the double derivative. Now, if my double derivative, if when I take my double derivative and substitute these values here, because I have 2, I want to know what 2 is at my double derivative, as well as I want to know what 2/3 is at my double derivative. So if I plug those in, if I get a positive number, if I get a positive number, then I am at a minimum. So we want to understand that a positive number means that we're at a minimum. And if we get a negative number, right? Negative number would mean that we're at a maximum. So we want to take the double derivative. No, right? Now the first derivative that we got, so dy dx was, remember it was 3x squared minus 8x plus 4. That was my first derivative. So my double derivative now is gonna, so my double derivative is gonna be 6x minus 8. So I want to evaluate now. So let's take stationary point 1. Right? Remember, it's the x. So we're talking about when x is equal to 2. So I'm going to substitute here. Right? I'm going to substitute right here. Let me clean this up. All right, let me go again. So I want to substitute right here. So we're talking about 6x minus 8 when x is 2. So this is saying 12 minus 8. This is 4. And this is a positive 4. So basically then, since this is a positive 4, I'm saying 2, 0 is a minimum. So at 2, 0, we are at minimum. All right. Now let's go for the next one here. So I want to evaluate on this side. I want to look at my 2/3, 32 over 27. The focus is on this though. Focus is on when x is equal to 2/3. So I'm going to substitute that 2/3, yeah, here. 3 into yourself 1, 3 into the 6, 2, 2 2s, 4 minus 8, and that will give me a minus 4. So you could see that this is a negative number. That means 2, this point here, we are at a maximum, right? We are definitely at a maximum for this point here. And there it is. We would have put that aside. So guess what, guys? Thank you for watching Daily Maths Concepts. If you have not yet subscribed, please subscribe, share, and drop a comment. All right. See you next time for the next.